So here in, I hope you can see this here, I have a cluster control up and running. We have a Galera cluster that I have on Amazon, a 3-node Galera cluster, and I've already installed HAProxy here that you can see here in the list here. But the way to install HAProxy here with MySQL cluster, sorry, with Galera here with cluster control, is we have a function called add load balancer, which allows you to install both HAProxy and Keepalived and set up HAProxy in a fault-tolerant environment using the cluster control web application. What you do is you select which database backend service that you want to have included in your load balancing group. You choose which server that you want to deploy HAProxy on. You can choose a name. You can choose some of the HAProxy settings here in this dialog, and then you can just install it automatically. You can also build HAProxy from source if you have some issues with your environment as well. And then after you have deployed HAProxy on your servers, the next step is just to install Keepalived and set it up in an active passive environment here with HAProxy. So you just choose HAProxy 1 and HAProxy 2, the active and the standby HAProxy servers that you want to use. You enter a virtual IP that you want your application to connect to, and then you just install Keepalived. And the configurations and things like that you've seen in the slides is basically the same that cluster control uses, but it's all automatic, and it's faster sometimes to do that through the cluster control application instead. And once you have that set up, you can access the HAProxy web application through the cluster control application by clicking on the HAProxy node, and then you get up the HAProxy's own version of HAProxy's own web application here, where you can monitor the progress of the HAProxy load balancer. With cluster control's next version, you'll be able to actually have these stats in line in the cluster control application as well. Okay, JJ, I think that's time for next poll.
Yeah, thank you, Alex. And just before we move on, we just wanted to ask all of you what type of MySQL cluster you currently use yourselves, of those of you participating today. So if you could again just let us know, just to give us an idea of what you're using yourselves in your day-to-day work. So whether it's MySQL cluster NDB or Galera cluster. Some of you may not have any clusters at all, so maybe you're using standalone mode, or you have some other cluster solutions. So it'd be great to know what it is that you're using. And I'll share the results of the poll, of course, again, once everyone had a chance to provide their answers here. So thank you for participating. I'm just going to close the poll and share the results. Right. So interestingly, we don't have anyone using MySQL cluster today, okay? But a lot of my master slave application, and then Galera cluster comes next, but kind of tied with standalone mode, which is interesting as well. I don't know if you have any comments on that, Alex, or if you want to move on straight away.
No, let's move up. I think we've seen this same type of polls before. It's usually a lot of replication deployments out there, and a few Galera that we see often.
Great, thanks for participating, and I'll just hide the results now.
Right, so let's continue with some deployment scenarios using HAProxy with different MySQL cluster types. So there were no one on MySQL cluster, then the B engine, I think in the poll, right? But MySQL cluster is an active shared nothing architecture. So all nodes that you deployed with MySQL cluster, the NDB cluster engine, are active. So there's no passive component here. And MySQL cluster consists of different types of components. You have an SQL nodes, which are basically the MySQL server, which act as a SQL proxy. Basically, that's basically for SQL-based applications to connect to, so that they can access the data nodes. And the data nodes is where the actual data is being stored in MySQL cluster. And for MySQL cluster, you also have so-called management nodes, which provides a cluster configuration file which describes the cluster setup. So with HAProxy and MySQL cluster, a good place to install and deploy HAProxy is on the management nodes, because the management nodes are running quite lightweight. The management processes are lightweight processes. They don't take up much resources, so you have plenty of available space, so to speak, on those servers. So what you can do is just deploy HAProxy on those management services. And of course, in a production environment, the recommendation is to have 2 management servers for redundancy. So this is also an excellent opportunity also to deploy HAProxy in a fault-tolerant deployment using Keepalived and a virtual IP, for example. As I mentioned before, the original connections are coming from the HAProxy server. So your SQL nodes here need to be able to, you have to set up grants properly, so the connections are able to be allowed to come from the HAProxy servers or the management nodes here in this case. One drawback here is there's an additional latency, because the application servers now need to connect to the HAProxy instances, which then connects to the SQL nodes and then to the data nodes. The benefit here is that you can scale out the SQL node tier without having changed your application tier. The application tier will connect directly to the virtual IP, and then you can scale out and scale down the number of SQL nodes that you have without having to change the configuration on the application side, for example. Another way to deploy HAProxy with MySQL cluster is to put HAProxy together with the so-called application servers. So what you do is, for each application server that you deploy, you put an HAProxy instance on that. And then you can scale out the application layer by adding more application servers. But then, of course, you have to add or install an HAProxy on that. And also, if you scale out the SQL node layer, you have to update the HAProxy instance configuration files in order to handle the newer SQL nodes. An alternative to put the HAProxy instance on the application server is to use, if you have a Java-based application, is to use the JDBC driver, and then load balance your requests across the SQL nodes using the JDBC driver. Of course, any configuration change needs to be propagated across all the application servers. For MySQL application, you usually use a standalone HAProxy server somewhere. And a popular way to use HAProxy here is to do a read-write splitting. So you direct writes to a MySQL master, and all reads are directed to MySQL slaves instead. And one way to do that is to create different backend configurations, one for the master and one for the slaves. Or you can use 2 separate HAProxy instances, of course. For Galera cluster, which is a synchronous replication cluster, and all nodes here are also active, so it means you can read and write to every node that you have here in a Galera cluster, as you know. One problem, or not problem, but one thing with Galera cluster is that if you come from a single MySQL server environment where your application has been running, and then migrate your application to Galera cluster, you might experience what's called deadlocks, because Galera cluster does what's called pessimistic locking on the node, but it does optimistic locking cluster-wide. Which means that there's high probability of deadlock if you have multiple clients writing to the same table, and also if they're hitting the same record at once. What happens is that the application will get an error back that says that there was a deadlock, right? And if you cannot change the application to make some changes to either the database schema or the queries that is being run, one way to fix that issue is to use HAProxy and configure HAProxy so that you have read-write splitting. So all the writes goes to one of the database nodes in your Galera cluster, while the reads goes to the other nodes. Or you only write to one database node. That's one way to fix this problem. Otherwise, if you don't have that kind of application problems or problems with deadlocks and things like that, it's very easy to just deploy HAProxy in a normal way using virtual IP and Keepalived and things like that. And with Galera cluster, it's very easy to scale out the performance of the Galera cluster by hiding, from the application layer, the configuration and the number of Galera nodes that you have, by just letting the application nodes, application servers, writing to a single virtual IP. So you don't have to do any configuration changes, propagation changes if you change the backend of your Galera cluster, for example. Another way to use Galera cluster with load balance is, of course, also to use JDBC, the JDBC drive if you have Java-based applications. HAProxy is primarily a TCP-based load balancer, and it's quite simple, but there are more specialized load balancer out there for MySQL specifically. So one very popular one is the MySQL proxy, which is coming out from Oracle, of course. With MySQL proxy, you can do a bit more. You can customize, and you can inspect the SQL scripts that comes in through pipeline. You can script it using Lua, for example. But those are more customized, more specialized for database, for MySQL, basically. But performance-wise, I think you get the best performance out of HAProxy because it does one thing really well, and that's just distributing the connections that are coming in. But if you need to have some kind of more of a specialized load balancer, which needs to inspect the queries that are coming in, one way to look at different alternatives is to look at MySQL proxy and also MaxScale that also does a lot of things in terms of customization. But for baseline performance, I think HAProxy will be the fastest load balancer out there if you just need a way to load balance connections that are coming in. All right, that's the last slide. If you need more information about MySQL load balancing and HAProxy, then you can go to our website. We have resources on that. We also have blogs, more blogs about this topic, and also webinars that you can check out.